Hello everyone, myself Dr. NCH Ramgopal, working as Associate Professor in Mathematics, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to today's presentation on random variables and probability distributions. Let us recall the previous session. In the last session, we have discussed the introduction to probability, all the definitions required to understand the concept of probability, and then the definition of random variable and types of random variable. Coming to today's presentation, today I would like to discuss the following things: discrete and continuous random variables, probability function, and what is probability mass function and density function, and what is the probability distribution and cumulative probability distribution function, and introduction to measures of central tendency. The random variables are two types. One is discrete random variable and the other is continuous random variable. A random variable is said to be discrete if x takes finite number of values. That means, here x takes x1, x2 and so on xn. So, for example, if you consider the experiment of tossing two coins, then the sample space contains capital S contains both heads or one head one tail. This happens in two different ways, and both tails. So, these are the outcomes of this experiment of tossing two coins. Now, here what is the actual definition of random variable? Random variable is a rule in that we assign a real number to each and every outcome of the experiment. For example, if the outcomes are not numeric, non-numeric outcomes are there, then we assign a real number to each and every outcome of the experiment. Here the outcomes are HH, HT, TH, TT. That means both are heads, both are tails, one head, one tail, one tail, one head, which are non-numeric. These are not numerical values. So, we assign a real number to these outcomes. So, before assigning the real number, first we need to define what exactly x denotes. So, let x be a random variable, let x be the random variable that denotes number of heads. So, here x takes the values, both are tails, that means there is no head. So, 0 heads, and in these two cases one head one tail is there. So, one head is possible, and here two heads are possible. So, x takes the values 0, 1, 2. How many values are there? Total 3 values, which is a finite number. Hence, this random variable capital X, which denotes the number of heads, is a discrete random variable. So, a discrete random variable capital X takes finite number of values. Similarly, if capital X takes infinite number of values, then the random variable is said to be continuous random variable. X takes infinitely many values. So, how can we denote that? For example, if x belongs to an interval a comma b, we know that between any two real numbers there exists infinite number of real numbers. Hence, here capital X takes infinitely many values. So, I can define the random variable as the set of all x values where x belongs to this a comma b. So, x lies between two real numbers, that means x takes infinitely many values. Hence, this capital X is a continuous random variable. Now, some examples of these discrete and continuous random variables. And coming to discrete random variable, the number of heads in tossing a coin, just now we discussed, 2 coins are tossed, so maximum number of heads is 2. If 3 coins are tossed, maximum we get 3 heads. If 4 coins are tossed, maximum number is 4. Similarly, number appeared in throwing a die. So, if a die is thrown, there are 6 outcomes, the outcomes are finite. So, it comes under discrete random variable. And number of defective items in a sample of bulbs. For example, there are 20 bulbs and out of 20, there are 3 defective bulbs. And if 5 bulbs are selected at random from this 20 bulbs, a sample of 20 bulbs, and X denotes the number of defective bulbs. And how many defective bulbs are there? 3 defective bulbs are there. So, X takes maximum 3. We cannot get 4 defective bulbs because there are only 3 defective bulbs. So, if we are selecting 5 bulbs randomly, there can be maximum of 3 defective bulbs and remaining 2 non-defective bulbs. So, X takes the maximum value 3, or we may get only 2 defective bulbs or 1 defective bulb or 0 defective bulbs. So, X takes finite number of values. So, this is a discrete random variable. Similarly, the number of printing mistakes per page. Per page hardly we may say we can say there may be 5 printing mistakes or 6 printing mistakes, for example 10 also even, but the number is finite. And number of telephone calls received by the operator. So, for example, per minute how many calls he is receiving? Maybe 5 calls, maybe 10 calls, and whatever may be the number is finite here. So, it comes under discrete random variable. So, these are the examples of discrete random variable. Now, coming to the continuous random variable, height of an individual, weight or age of an individual, temperature, time, all these comes under continuous random variable. Now, let us define the probability function. So, here we have a random variable capital X, and which takes some values, for example, x1, x2, etc., xn. That means, it is a discrete random variable, let us suppose. Now, if we have a function p of x to find the corresponding probabilities of these n values. For example, if x1 is the random variable, if you calculate p1 using this function p of x, p2 using the same and so on pn. So, this function is called the probability function of the random variable x. Similarly, we can define the same in the case of continuous random variable also. So, a function using which we are able to calculate or find the probabilities, corresponding probabilities, that is called a probability function. So, for a random variable capital X, the real valued function p of x such that this p at capital X equal to small x is probability of that small x is called the probability function of the random variable capital X. So, simply using the function using which we can calculate the probabilities is called probability function. Now, here since the random variable capital X is of 2 types, discrete random variable and continuous random variable. So, in both cases we have the probability function in both cases, discrete and continuous. If capital X is a discrete random variable, then the corresponding probability function is called probability mass function. If the random variable is discrete, then the corresponding probability function is called probability mass function. So, the definition is simply the probability function of a discrete random variable is known as probability mass function, or if capital X is a discrete random variable, then the function p of x is called probability mass function if it follows the following conditions or which satisfies the following conditions. The first one is p of x greater than 0 for all x. So, p of x greater than 0, what does it mean? The probability must be positive, that is the first point. Even greater than or equal to 0 must be non-negative value for all x values, since we won't get the probability negative. So, minimum value is 0 and maximum is 1. So, 0 less than or equal to p less than or equal to 1. So, probability can be a non-negative value for all x, and sigma p of x is 1. Since here the random variable is discrete, this comes under discrete case and x takes finite number of values. So, for this is the example, if x takes a finite number of values, n values, there will be n probabilities. If you add all the probabilities, sigma pi will be 1. That means, this represents the total probability is always unity. The total probability is always unity. So, the probability function should satisfy these conditions. Since the random variable is discrete, here to find the total probability we use the sigma notation since the number is finite. Hence, P of x is called probability mass function if capital X is the discrete random variable and P of x is a non-negative value and total probability is unity. Now, coming to probability density function. In the case of continuous random variable, the probability function is called probability density function. In the case of discrete random variable, it is called probability mass function PMF, whereas in the case of continuous random variable, the function probability function is called probability density function PDF, and which satisfies the conditions P of x equal to, here the probability of the random variable is denoted by a function f of x, and again this must be a non-negative value greater than or equal to 0, since the probability can be non-negative, and here that always the property is the same, total probability is always unity. In the case of discrete random variable, since the values are finite, we can add all the corresponding probabilities. So, we can denote using sigma notation, but in the case of continuous random variable, x takes infinite values, x takes infinite values. How can we add infinite values directly using summation? So, that is why we use integration. Integral minus infinity to plus infinity f of x dx is 1. Again this represents the same, the total probability is 1. So, integral minus infinity to plus infinity f of x dx. Since this f of x gives the probability, this gives the total probability which is always unity. Hence, the probability function of a continuous random variable is called probability density function. The probability function of a discrete random variable is called probability mass function. Now, coming to the probability distribution. So, here we are dealing with random variables. Let x be a random variable. For example, x denotes discrete random variable. Let us consider discrete random variable. Then x takes finite values x1, x2 and so on xn. Now, for the given random variable, the probabilities can be obtained using the corresponding probability function P of capital X, and using this function let us calculate all the values P1, P2 so on Pn, all the probabilities. Now, the set of these two, the random variable and the corresponding probabilities, the set of these two values is called probability distribution, or simply we can denote this using a table x, the first row x, the random variable values x1, x2 etc. xn, and the second row corresponding probabilities P1, P2 and so on Pn. Just arrange all these in the form of a table. So, which is called the probability distribution, simply distributing the probabilities to the corresponding values of x. For that we use the probability function. In the case of discrete random variable, we use probability mass function. In the case of continuous random variable, we use probability density function. So, this combination of values x and corresponding P of x. Let x be a random variable which takes the values x from x1, x2 etc. xn. Let us find the probabilities and form in the arrange these values in the form of a table. So, this is called probability distribution. A simple example, 3 coins are tossed, 3 coins are tossed. Now, the question is find the probability distribution of number of heads. The experiment is 3 coins are tossed. So, find the probability distribution of number of heads. Solution. It is given that 3 coins are tossed. Hence, the sample space S contains 2 power 3 elements, that means 8 elements. What are those elements? All 3 heads or 2 heads, 1 tail, and this is possible in 3 different ways: H, T, H, T, H, H, and 2 tails, 1 head, and there are 3 possibilities for this. So, THT and then HTT, and there is another case all tails. Now, the question is to find the probability distribution of number of heads. We are talking about number of heads. Hence, let capital X be a random variable that denotes number of heads. So, here 3 coins are tossed. So, maximum we get 3 heads or else 2 heads or else 1, or complete failure case will be there always 0 heads, all tails. This is the complete failure case, all tails. So, these are the values of X. Now, let us find the corresponding probabilities using the classical definition of probability. So, the probability of an event E is N of E by N of S, the classical definition of probability, favorable number of ways divided by total number of ways. So, here probability of getting 0 hits out of here the total number of sample elements N of S is 8. Out of 8 outcomes, how many are favorable for the first value of X? 0 heads is possible only in one case. So, 1 by 8 is the probability of getting 0 heads. Similarly, all 3 heads, only one possibility, and one head occurs in 3 different cases. So, 3 ways, 3 by 8, and 2 heads here 3 by 8. So, this is called the probability distribution of number of heads when 3 coins are tossed. And here you can identify one thing, the probabilities, all the probabilities are greater than or equal to 0. In this particular example, greater than 0. And then the sum of probabilities, if you add all these 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8, denominator is 8, numerator is 8. So, total probability is always 1. If you add the total probabilities, you will get 1. Similarly, 2 dice are thrown, 2 dice are thrown. Find the probability distribution of sum of the 2 numbers appeared, sum of the 2 numbers appeared. Find the probability distribution of sum of 2 numbers appeared. So, here since 2 dice are thrown, 2 dice are thrown. So, what is the sample space? Sample space contains 1 1, 1 2, 1 6, like this, 2 1, 2 2, 2 6, 6 1, 6 2, and so on 6 6. So, total number of outcomes is 36, N of S is 36. There are 36 outcomes in this particular example. Now, first we need to define capital X. Let capital X be a random variable that denotes sum of the 2 numbers. Sum of the 2 numbers appeared. And first, what are the possibilities for this sum that we need to identify, so that we can write the values of X. So, here 1 comma 1 is one of the outcomes, and sum of these 2 values is 2. So, 2 is possible. Now, the sum 1 is possible in this case? No, it is not possible, since the minimum number is 1, and if both dice show 1 comma 1, then the number is sum is 2. So, 3 is possible, 4 is possible, 5 and so on. Maximum is 6 comma 6, 12. Maximum is 12. So, these are the values of the random variable capital X. Now, coming to the probability. Now, how to find the probability of these events? The probability of an event is given by the favorable number of cases by total number of cases, that gives the probability of an event. So, in how many ways we get the sum 2? Out of 36 ways, there is only one possibility 1 comma 1. So, 1 by 36 is the probability of getting sum 2. Similarly, to get the sum 12, there is one and only one possibility. So, 1 by 36 here, and sum 3 is possible in two ways, 1 2 and 2 1, 2 by 36, sum 4 3 by 36 and so on, sum 5, to get sum 5, 2 3, 1 4, 2 3, 3 2 and 4 1. So, 4 cases out of 36 and so on. So, this is called the probability distribution of sum of the two numbers appeared. Next, cumulative probability distribution function. Simply, the cumulative probability distribution function is the sum of the probabilities. So, the probability that the value of a random variable is less than or equal to some real number. For example, capital X less than or equal to X. For example, X less than or equal to 4, where X takes from 0, 1, 2, 3, 4, 5, 6, 7, 8, let us suppose. X less than or equal to 8 means corresponding probabilities P0, P1, P2, P3 and so on. These are the corresponding probabilities. Now, X less than or equal to 4 means P0 plus P1 plus P2 plus P3 plus P4 up to P4. We consider the sum of these probabilities. So, it is denoted by capital F of X and is defined as X less than or equal to X. In the case of discrete random variable, we use sigma notation. So, 0 to X, and in the case of continuous random variable, integration from minus infinity to X. So, here capital F of X is the cumulative probability distribution function. Cumulative probability distribution function. And there is a relation between capital F of X and small f of X also. Capital F is the cumulative distribution function, small f is probability density function or continuous case density function and mass function in the case of discrete. So, the relation between this capital F and small f is given by capital F of X is d by dx of small f of X is d by dx of capital F of X. So, that means the probability density function can be obtained if we have the cumulative probability distribution function, simply differentiate that with respect to X. For example, we have f of X, the probability density function, and we need to find capital F of X. To find capital F of X, just integrate. Capital F of X is given by integration of small f of X dx. So, if cumulative probability function is given, differentiate it to find the probability density function. If probability density function is given, integrate it to get the cumulative probability function. And now, introduction to measures of central tendency. In this session, just I will introduce these things, and in the next session, we will go through individually one by one about these measures of central tendency. The central tendency is a measure defined as the number used to represent the center or middle value of a set of data values. For example, if we have a set of values x1, x2, x3, x4, x5, for example, 5 values are there. So, these measures deal with the center value. For example, mean or average, we can call it as average also, median, about the middle point, and mode, and variance, standard deviation. So, these are the statistical measurements that we are going to calculate for the given random variable. We can find the mean or average or expectation of the random variable capital X. Similarly, variance of X, standard deviation of X. So, here mean in general denoted by, the mean is denoted by mu or expectation of X or expected value also E of X. A median, mode, generally we can calculate, and variance sigma square, it is denoted by sigma square, and standard deviation is the positive square root of variance denoted by sigma. So, in the next session we are going to define these central measures, and then we calculate mean, median, mode, variance, standard deviation for the given probability distribution also. Now, coming to today's session, In today's session, we have discussed about discrete random variable and continuous random variable along with examples, and then probability function, and this probability function is two types: probability mass function PMF, probability density function PDF. Similarly, there is another probability distribution function which is called cumulative probability distribution function denoted by capital F of x, and mainly the probability distribution of a random variable capital X. So, if capital X values are given, for example, x1, x2, x3, x4, there are 4 values for x. Let us calculate the corresponding probabilities and form a table with all these values. The first row denotes the random variable values, second row denotes the corresponding probabilities. So, this is called probability distribution. And also we have discussed, we introduced the measures of central tendency, the mean, median, mode, variance, standard deviation, etc. In the next session, we are going to discuss what is the formula to find the mean, median, mode, variance and standard deviation of a random variable capital X or the distribution. For example, if we have a probability distribution like this, we can find the mean of this probability distribution, mean of the distribution, variance, standard deviation, etc. Thank you.